Okay, so we finished with this example yesterday. So there's one more definition, some notations, and then 2 more examples before we get into the actual examples in the homework. So, a derivative. I don't know what color you used. I used blue. If y equals f of x, then the derivative of the function f with respect to x is the function f prime whose value at x is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So these ones are like generic. The other ones that we've done are like at a point where they give you like basically what's getting plugged in. These ones do not. And obviously this is for all values of x where the limit exists. What are they doing? So some ways to denote a derivative, and they all mean the same thing. It's just the different ways that you may see it written. You could have delta y over delta x, which obviously is like slope. You could have dy over dx, so that means the derivative of y over the derivative of x. And this is in Leibniz notation. Or we can have y prime, which is prime notation. And literally all of these mean to do the same thing. Take the derivative.
Is this our first time working with derivatives?
Yeah, this is usually not taught until calculus, like actually, but
Because
it's just a random note.
I think there was like derivatives on that
It's like the
SAT.
4th color.
I did not know.
Really?
Well, I don't know. Well, it may have been ACT or SAT.
It's possible.
I mean, I didn't see.
I didn't see any on the SAT, but it's definitely possible on ACT.
Yeah, I just guessed.
Because the ACT has stuff that a lot of times you don't get till senior year, so it's definitely
Yeah,
possible.
that's why I'm not taking it into.
I took my ACT, I think January of my senior year.
I think I'm taking mine in June, so then I can retake both of them.
Yeah. I just knew I wasn't retaking them. Because I knew I would do well enough to get into the colleges I wanted to. And literally even before my scores came in, I'd already gotten accepted where I...
Yeah.
Not that I ended up
Well,
going
like,
to any of the colleges right away, but
most
Thomas
of
Nelson didn't
the-
care, but...
Most of the colleges I'm applying to, like, are test optional, so, like...
Yeah, me too.
Yeah. Some of them will get you, like, a scholarship potentially,
Mhm.
but
Yeah.
that's about it. All right, so some more examples for finding the derivative. Now, this first one that I'm going to do, I'm going to show you the shortcut way after I do it, the way that they want you to do it here, so that I guess if it does come up on your SAT or your ACT or something that you've seen it before, and it'll go faster. The second one, there's too many rules that it won't work right now, so we'll just have to, or it would be too confusing to explain right now, because you don't have enough knowledge of derivatives yet. So we're going to use this method. So, the first one is we're going to find f prime of x if f of x is equal to x squared. Now, normally, if I was finding this derivative, the way that I would normally do it, one line, and I'd be done.
Oh, well, I like that.
But we have to do it the long way, so it's gonna take a little longer than that.
2 lines?
Like 8.
Oh.
Oh.
depending on how you write, like if you write your like limits like on 2 separate lines, or if you write them as one, then that'll make a difference. But all right, so again, I'm just gonna rewrite the formula just so that we have it here on the screen. So the limit as h approaches 0 of f of x plus h minus f of x all over h. So now, anywhere I see an x in my original equation, I'm plugging in first x plus h, then I'll be plugging in x. So the limit as h approaches 0 of x plus h squared, okay, so that takes care of this first part, minus x squared. So in this case, because there's nothing else with it, it just gets copied down, divided by h. So the limit as h approaches 0 of x plus h squared is a perfect square trinomial, so that factors into x squared plus 2xh plus h squared minus x squared over h. So my x squareds cancel. And then I can take an h out of the top. So I would have the limit as h approaches 0 of h times 2x plus 1 over h. Nope, hold on. That's an h. 2x plus h. I wrote a 1. So then h's cancel. So you now have the limit as h approaches 0 of 2x plus h. If h goes to 0, I'm left with 2x. So the derivative of x squared is 2x.
Oh, I see. Okay. It was a lot of steps, but not necessarily like
Yeah.
complicated.
So the shorthand way, so if you have x to the n is your original, the derivative is n x to the n minus 1.
Wait, what?
Wait, what? Can you like?
Yeah, so if your original, I'm just doing this generically, so no numbers. So if my original, like this was x squared, was x to the n, where n can be any number, okay, then what you do is you put it out front and you subtract 1 from it.
You put n out front and then.
So you move the exponent to the front
Okay.
and you subtract 1 from whatever was there. So this one was x squared. So I move it out front. So I put the 2 out front, keep the x. 2 minus 1 is 1, so it's just 2x.
2x.
That's
Oh.
So a lot less work.
Yeah.
That typically makes life a little easier.
Wait, on the quiz, do we have to do it like the long way?
If there's something like this, you can do it the short way if you know the short way. But if it's like the one that we're getting ready to do, then you would need to do it the long way. Because you're not, I'm not, well, I could explain to you. I will show you how to do it the shorthand way, but it's a little different.
When you like put the x squared in for the f of x, like at the beginning. Yeah, like why is the x plus h like the whole thing squared?
Because you're putting in x plus h for x up here. So x squared is now, this was f of x, but I want f of x plus h. So x plus h is going in for x.
Okay.
So it's like when we did the problems where it was like f of 2 is equal to blah, blah, blah. Anywhere there was an x, we replaced it with the number 2. but now it's just getting replaced with whatever's in here.
Okay.
Any other questions about that one? So if I were to give you x to the 4th, what would the derivative be?
4x to the 3rd.
Yep.
4x.
Now, if, just because, y'all seem intrigued, if I had 3x to the 3rd, any ideas about that one?
Would it be like 9x squared?
Mm-hmm. Yep, so you multiply. So when you put this out front, it's being multiplied by whatever's in front.
Okay.
So it would be like 9x squared. If you had something like 3x to the 1/3, what about that one?
Wait.
Oh, x.
X to the negative 2/3.
Yes.
Yep. Well, y'all got a whole chapter of calculus down now. No, I'm just kidding. I'm just kidding. All right. So the other one that's just in the plot twist. Y'all can take this AP exam in 2 weeks.
Yeah, right.
Minus all the word problems and area and integrals and all that
Yeah,
stuff. We'll save that for later.
Yeah, we don't need it.
Well, integrals are basically the reverse of what we're doing. So if you can do this, you just have to work backwards. But there's a lot of rules for integrals. So integrals take a long time. It's this fancy thing.
Oh my gosh, I've seen that before. I don't know.
It's on the front of the calculus book, probably. All right, so we're finding dy dx, which is just find the derivative, if y is equal to 1/x. So we're going to do it the long way, and then I'll show you the short way. So I'm not going to rewrite the formula. It's the same formula every time. We're replacing it with x plus h first, then just x. So change colors. All right, so dy dx is equal to the limit as h approaches 0 of 1 over, I'm replacing x with x plus h from the formula, minus 1 over x, f of x, all over h. Any suggestions?
We could, I don't know if we're allowed, can we like get common denominator?
I should do that. That would be a good idea. How do I do that?
I guess just multiply them by each other.
Yeah.
So I'm going to multiply, I'm just going to save a separate writing. So I'm going to multiply this one by x over x, and I'm going to multiply this one by x plus h over x plus h. So I have the limit as h approaches 0 of, I'm going to go ahead and write this all as one combined fraction, just again save another step. So x minus, and you can either do it as parentheses x plus h, or you can do minus x minus h, because this minus is going to everything, over what is it, x times x plus h. I would just leave it like that for now. All over h.
Oh.
I forgot about that.
So on top, x minus x, so that goes away. Okay, dividing by h is the same as multiplying by 1 over h. Okay, it's not a fraction on the bottom. So I now have, try to make this look a little nicer. As h approaches 0, I have negative h over x times x plus h times, now I don't want to divide again, so that's why I'm going to write it as 1 over h. So my h on top and this one over here on the bottom cancel. So I now have the limit as h approaches 0 of -1 over x times x plus h. So if I put in 0 for h, I'm left with -1 over x times x. So it's going to be equal to -1 over x squared.
So it's basically just plugging in and simplifying.
So it's all stuff you've done before, other than other than the limit itself. But you've done the math of how to solve these before.
Yeah, just like
So.
like more numbers.
So it's just basically just either.
Yeah. So if I were to do this the shorthand way, y equals 1 over x. Can't do it as it is like this because you won't get the right answer. You need to move x to the top. So to do that, I would write that as x to the -1. We agree that's equal to 1 over x. So then the derivative
Would be
X.
negative x
True. -X.
to the negative squared.
and then we would move x back to the bottom, so -1 over x squared.
Okay.
Oh, so
That's why I said it's just a little different
Oh, you have to
because
make it
of
back.
you have to move it. Like technically speaking, this one up here that I asked you about, you should really rewrite this as 1 over x to the 2/3, but
Okay.
it's fine.
Oh, because it like started as a fraction? Or-
Well, because you shouldn't have a negative exponent, but
Oh.
I a lot of times just leave
Okay,
it. But
yeah, I see. That's okay.
all right, that's all the notes.
Yay!